The sky above Berlin on March 6, 1944, erupted into chaos at 28,000 feet. The 56th Fighter Group clashed with German fighters in what would become the most massive aerial battle Europe had yet witnessed. What unfolded that day would astonish both the American pilots and their Luftwaffe adversaries. When German fighters attempted their usual escape, they climbed steeply away from pursuing Americans. For 12 months, this maneuver had worked almost flawlessly. The heavy, powerful P-47 Thunderbolt simply wasn't built to chase a climbing Focke-Wulf 190 or Messerschmitt 109 to altitude. Yet on this particular morning, everything changed. American pilots kept their guns trained on German fighters through climbs that should never have been possible. At altitudes pushing toward 28,000 feet, with both aircraft operating at maximum power, the Thunderbolt pilots squeezed their triggers. German fighters trailed black smoke and erupted in flames. Parachutes blossomed across the sky as desperate pilots bailed out. When the fighting ended, the 56th had destroyed 11 German aircraft without losing even a single Thunderbolt. The transformation was complete. A simple modification to the Thunderbolt's propeller had fixed the aircraft's most crippling weakness and completely shifted the tactical balance across the European theater. The story behind this breakthrough began months earlier in the engineering labs of two major American propeller manufacturers during the freezing winter of 1943. While bombers fought their way through German skies and fighter pilots filled report after report, describing German fighters escaping by climbing higher, engineers raced against time to solve what seemed like a straightforward problem. The Pratt & Whitney R2800 engine cranked out 2,000 horsepower, yet the Thunderbolt climbed sluggishly and inefficiently. The thin, narrow-bladed Curtiss electric propeller, mounted on early production models, simply couldn't transform all that raw power into upward thrust. These propeller blades had been engineered for high-speed cruise, optimized to slice through the air with minimal resistance above 350 miles per hour. When pilots climbed at slower speeds, with the engine roaring at full power, those thin blades bit into far too little air. The propeller couldn't grab enough air to efficiently convert horsepower into the lift needed for climbing. Engines screamed and consumed fuel and threw off tremendous heat, but the aircraft refused to climb with any real vigor. The engineering problem was both obvious and frustratingly difficult. January 1943 found Alexander Kartveli at Republic Aviation's engineering headquarters on Long Island examining disturbing combat reports from England. German interceptors dove straight through bomber formations, attacked, then simply pulled into steep climbs and vanished. American Thunderbolts couldn't follow. The performance data made grim reading. Early Thunderbolt models took forever to claw their way to combat altitude. The Focke-Wulf 190A and Messerschmitt 109G climbed to those heights far faster. This gap in performance directly translated into dead American pilots. Commanders at various Air Force bases whispered doubts about whether the Thunderbolt deserved to stay on the front lines. Kartveli grasped the core engineering challenge. Propeller efficiency depends on matching the blade design to how the engine will operate. Thin blades worked beautifully at high speeds because slim profiles created minimal drag. But during climbs at low speeds, pilots needed broad blades that could grab massive amounts of air and transform power into upward thrust. Enlarging the blade area looked easy in theory, but proved devilishly complicated in practice. Every change to a propeller's design rippled through the entire aircraft system. Incorrect blade shapes could trigger vibrations that would shake the engine right off its mounts. Improper weight distribution could create harmonic resonance, leading to catastrophic structural collapse. Wrong torque characteristics could make the aircraft impossible to control during takeoff and landing. Republic needed wider blades that could integrate seamlessly into existing aircraft without demanding massive overhauls. The competition to solve this problem featured two of America's top manufacturers. Curtiss-Wright, maker of the original narrow-blade propeller, and Hamilton Standard, which produced propellers for countless military aircraft. Whoever won would see their design manufactured in quantities exceeding 10,000 units. More critically, it would determine how many American pilots came home alive. Engineers at both companies worked furiously through the winter of 1943. They tested blade shapes in wind tunnels, calculated stresses, built prototype hubs and pitch mechanisms. Every day counted as American pilots died, while technicians refined blade chord lengths and twist patterns. Hamilton Standard's engineers took a radical approach to propeller design. Instead of thin, knife-like blades that cut through air, they conceived wide, paddle-shaped blades that grabbed air much like rowing oars pushing through water. The chord of these blades would expand dramatically. The blade profile would stay nearly rectangular along most of its length, before narrowing gradually at the tip. Traditional aerodynamicists found this design almost crude. Yet wind tunnel results shocked everyone. The design produced far greater thrust at low air speeds while surrendering barely any top-end performance. Curtiss-Wright countered with their own wide-blade design, preserving a more conventional elliptical blade profile while vastly increasing overall surface area. Curtiss added blade extensions at the root to smooth airflow into the propeller hub and dampen vibration. Both designs represented tremendous leaps forward compared to the original narrow blades. Republic Aviation received prototype propellers from both manufacturers in April 1943. Evaluation commenced right away at Republic's facilities and at Wright Field in Ohio. Republic's test pilots methodically flew both designs through their paces. Results showed both Hamilton Standard and Curtiss propellers delivered nearly identical performance gains. Climb rates shot upward dramatically with either one. Hamilton Standard's design operated just slightly more smoothly thanks to its hydraulic pitch control. The Curtiss design meshed more readily with existing aircraft systems and could be retrofitted to Thunderbolts already flying in England more easily. Neither design dominated across all measures. The Army made a decision driven by practical manufacturing realities. Both designs would move into production. Hamilton Standard propellers would equip brand new Thunderbolts rolling off Republic's assembly line, beginning with the P-47 D-22 variant. Curtiss paddle blade propellers would be installed on Thunderbolts built at the Evansville facility in Indiana and distributed as retrofit kits for aircraft already stationed in England. This approach prioritized getting improved aircraft into combat quickly, rather than spending months determining theoretical superiority. The two-source method also muddied German intelligence gathering. Manufacturing and testing pushed timelines back. Production ramped up in June 1943, yet the first operational aircraft didn't arrive in England until late December 1943. Throughout December, Thunderbolts touched down at RAF Wattisham, where ground crews installed the new propellers. The 56th Fighter Group, based at Boxted in Essex, completed the transition by early January 1944. Group Commander Lieutenant Colonel Hubert Zemke immediately grasped what these propellers meant tactically. Dramatically enhanced climbing performance allowed his pilots to engage German fighters using vertical maneuvers that would have been suicidal with the old propellers. Through January 1944, Zemke drove his pilots through intensive training, forging new combat tactics specifically designed around the paddle blade Thunderbolt's superior climbing ability. He showed pilots how to engage German fighters in climbing spirals, maneuvers previously far too dangerous. He devised techniques where pursuing Thunderbolts would pitch up sharply if enemies tried to climb away, trading speed for altitude, then dive back down onto targets with accumulated speed. The old narrow blade propellers would have left Thunderbolts wallowing helplessly at low speed. With paddle blades, these maneuvers became deadly offensive weapons. January 4, 1944, marked a breakthrough. The 56th Fighter Group launched its first mission with every single aircraft carrying paddle blade propellers. Pilots immediately sensed something extraordinary. 7-ton fighters climbed with enthusiasm that should have been impossible. Energy retention during vertical maneuvers changed completely. Thunderbolts now trailed German fighters through climbing escape attempts without losing contact. Combat would reveal the true capability. Operational debut arrived during escort runs in late January and February 1944. American pilots encountered situations where German pilots executed their proven escape tactics, only to find pursuing Thunderbolts matching their climbs. German aviators initially wondered whether they faced a brand new American fighter type. As intelligence officers reviewed gun camera film clearly showing standard Thunderbolts performing this miracle, confusion rippled through Luftwaffe squadrons. How could the same aircraft they'd successfully evaded for an entire year suddenly match their climb performance? March 6, 1944, delivered unmistakable proof. Lieutenant Colonel Zemke led 48 Thunderbolts on bomber escort toward Brunswick, routing over Berlin. Luftwaffe controllers scrambled more than 80 Messerschmitt 109s and Focke-Wulf 190s to intercept the incoming bomber stream. As bombers approached at 24,000 feet, German fighters launched their traditional assault, diving through formations, then climbing steeply to break away from escorts. Throughout the battle, Thunderbolt pilots matched German fighters in vertical engagements for the first time. Captain Robert Johnson, Lieutenant Walker Mahurin, and other 56th Group pilots intercepted German fighters in climbing battles and destroyed them at high altitude. The group claimed 11 victories without losing a single Thunderbolt. Most importantly, not one bomber in their formation fell to German guns. German pilots landing after the Brunswick engagement radioed disturbing news. American Thunderbolts had climbed with them. Many insisted they must have faced a new fighter type entirely. When shown gun camera footage showing standard P-47s performing as described, Luftwaffe intelligence fell into deeper confusion. Technical experts needed to understand what had fundamentally changed. The breakthrough came from examining wreckage in early February. A downed P-47D-23 arrived at the Luftwaffe test facility at Rechlin. Technicians inspecting the aircraft immediately spotted the propeller. The blades were vastly wider than those on previously captured Thunderbolts. The technical intelligence report described the new design, but initially misunderstood its importance, suggesting it probably improved takeoff performance rather than combat effectiveness. This misinterpretation cost the Luftwaffe precious weeks. Throughout February 1944, more Thunderbolt groups transitioned to paddle blade propellers. The 4th Fighter Group received theirs in early February. The 78th Fighter Group finished conversion by mid-February. By month's end, 6 of 8 Thunderbolt groups in England flew paddle blade-equipped aircraft. Each group immediately saw their combat effectiveness jump. German fighter losses mounted as Luftwaffe pilots found their standard escape maneuvers no longer worked. On February 21, 1944, Jagdgeschwader 26 lost 7 Focke-Wulfs in a single engagement with the 56th Group. The unit commander, Major Klaus Mitusch, filed an after-action report revealing deep frustration. His pilots had fought according to established tactics, disengaging through climbing attacks when pressed hard. Every pilot attempting this maneuver was shot down. Mitusch demanded immediate answers about whether Americans had fielded a new fighter and whether existing doctrine remained valid. Luftwaffe intelligence provided no clear answers. German understanding gradually improved through observation and crash analysis. By March 1944, Luftwaffe intelligence recognized that American engineers had modified the Thunderbolt's propeller to generate greater thrust at low airspeeds, particularly during climbs. Reports circulated warning that American fighters could now compete in vertical combat, recommending engagement only while holding clear energy advantage and breaking off through level high-speed flight instead of climbing to escape. Implementing fresh tactical doctrine across hundreds of fighter squadrons proved impossible. Pilots who had survived an entire year by climbing away couldn't instantly override their survival instincts. The massive scope of this transformation became undeniable during Big Week. The enormous bombing campaign targeting German aircraft production facilities in late February 1944. From February 20 through 25, the 8th Air Force launched over 3,800 bomber sorties, protected by more than 3,600 fighter sorties. The vast majority of American fighters were paddle blade Thunderbolts. The Luftwaffe committed over 2,000 sorties in defense. Germans lost roughly 355 fighters destroyed, with another 100 damaged beyond repair. American fighter losses totaled just 28 aircraft. The exchange ratio had shifted dramatically in America's favor. Thunderbolt pilots discovered that paddle blade propellers opened opportunities beyond simple climbing advantage. Increased thrust at lower speeds improved acceleration following dives, allowing Thunderbolts to build speed faster after high-speed passes. Pilots could execute dive and climb attacks repeatedly, holding the offensive throughout prolonged fights. Superior thrust also boosted turning performance at lower speeds. While Thunderbolts still couldn't outmaneuver Messerschmitt 109s or Focke-Wulf 190s in flat horizontal turns, they maintained enough energy in turning climbs to prevent German fighters from gaining angular superiority. Major Francis Gabreski, leading the 61st Fighter Squadron within the 56th Group, became the most enthusiastic advocate for what pilots termed the climbing spiral. Gabreski would close on a German fighter at similar altitude, typically around 24,000 feet. Rather than attempting a horizontal dogfight, he'd maintain airspeed and pull into a climbing turn. German pilots, seeing the Thunderbolt climb, frequently followed, expecting the American fighter to lose energy and become defenseless. But with paddle blades, P-47s preserved their climb rate even while turning hard. Gabreski would circle upward through 2 or 3 complete rotations, systematically bleeding the German fighter's energy until the enemy either stalled or was forced to break away. With the German fighter now at low speed and maximum altitude, Gabreski would reverse, plunge onto the target, and open fire from a position where escape was impossible. Gabreski finished his career with 28 aerial victories flying Thunderbolts, the highest-scoring American ace in Europe flying a single aircraft type. Nearly all these triumphs came after his squadron received paddle blade propellers. In interviews after the war, Gabreski repeatedly credited the new propeller design as the most vital element in transforming the Thunderbolt from a defensive fighter into an aggressive killing machine. The transformation required surprisingly few modifications to how pilots trained on the aircraft. These planes simply responded to what their pilots commanded, preserving energy in situations where the earlier narrow-bladed Thunderbolts would have lost altitude dangerously. The paddle blade program showcased American industrial strength functioning at peak efficiency. Moving from initial drawing board to full operational deployment took merely 9 months. 2 separate manufacturers designed, thoroughly tested, and started producing 2 distinct propeller types. Republic Aviation retooled production at 2 separate facilities. The Army Air Forces established fresh maintenance protocols, taught mechanics the new procedures, and transported countless propellers across the Atlantic in massive supply operations. Nothing about this was technically revolutionary on its own. The real achievement came from the sheer speed and the enormous scale with which everything was executed. The United States spotted a crucial problem in aircraft performance, then fixed it before Germany could even respond with countermeasures. German engineers possessed the technical expertise to engineer similar advances. Both Messerschmitt and Focke-Wulf had experienced propeller specialists who grasped the aerodynamic advantages of expanded blade surfaces. Yet the German wartime economy in 1944 simply couldn't manage rapid upgrade campaigns. German fighter production was running flat out, concentrating on churning out proven designs in quantities large enough to offset combat casualties. Rolling out fresh propeller types would have demanded complete factory retooling, new aircraft testing certifications, revised technical manuals, and mechanic retraining across the entire system. Halting production lines would squander precious fighter aircraft precisely when Germany desperately needed every single plane. The Germans faced an impossible bind. They should have matched American improvements, but the manufacturing disruptions made that impossible. This revealed the gap between how Americans and Germans approached fighter development. American engineers favored practical solutions that could be deployed immediately. The paddle blade propeller wasn't the most aerodynamically refined design ever created. It produced additional drag compared to thin blades at peak velocities. It weighed more, needing stronger hub structures and more complex pitch regulation systems. Yet it fixed the climbing problem without consuming years perfecting every technical detail. German engineers frequently chased theoretical excellence while neglecting actual results. German propeller engineers pursued advanced variable pitch mechanisms that would theoretically surpass crude American paddle blades on paper. These sophisticated concepts rarely moved beyond the drafting table, never appearing in combat units in substantial numbers. By spring 1944, the paddle blade Thunderbolt had become the backbone of American fighter escort operations across Europe. The aircraft stopped being a stopgap solution, waiting for replacement by the longer-reaching P-51 Mustang. The Thunderbolt had transformed into a powerful air superiority platform that dominated most engagements against German opposition. The psychological shift was profound. Bomber crews that had helplessly watched German fighters disappear upward throughout 1943 now witnessed enemy aircraft getting cornered and destroyed in climbing battles. German pilots, already shaken by mounting American numerical advantage, entered a situation where their tactical strengths had vanished. The Focke-Wulf 190, designed to outperform the Thunderbolt across nearly every metric, discovered itself matched or beaten in the single vertical arena where it held unquestionable advantage. The Messerschmitt 109 couldn't depend on zoom climbs to break contact anymore. German fighter losses accelerated through spring 1944. Seasoned aviators who'd survived years of air combat got shot down by Thunderbolts they genuinely thought they'd eluded. The full scope materialized during D-Day preparations. Throughout May 1944, American fighters mounted relentless operations seeking air command over France. P-47s ranging across northern France hammered German airfields, decimated parked aircraft, and pounced on any Luftwaffe fighters attempting interference. The paddle blade versions proved exceptionally lethal during fighter sweeps. When German aircraft took off to intercept, they typically climbed from lower positions to reach American fighters flying at 20,000 to 25,000 feet. Thunderbolts dove on these struggling German climbers, struck hard, then zoomed back upward before Germans could respond. June 6, 1944. Allied invasion forces landed on Normandy shores as Thunderbolts patrolled constantly above. German fighters charging the landing fleet or supporting ground defense got intercepted and eliminated by paddle blade-equipped P-47s time and again. The Luftwaffe managed barely 100 combat flights over the beaches during that first critical day. American fighters executed over 8,700 missions in that same 24 hours. Such overwhelming dominance came possible because American fighters killed at ratios of 4 to 1 or better. The paddle blade modification, removing the Thunderbolt's single biggest disadvantage, directly enabled the air superiority necessary for invasion success. The numbers showed precisely what pilots experienced. In the opening quarter of 1944, before paddle blade propellers spread throughout fighter squadrons, American aircraft in Europe managed roughly 1.8 kills for every enemy fighter lost. By mid-year, as paddle blade variants equipped most American fighters, that ratio jumped to 3.2 to 1. By autumn, it climbed to 4.6 to 1. This dramatic improvement wasn't purely from propeller changes. American fighter numbers kept growing, pilot proficiency was rising, and Germany was replacing veterans with inexperienced replacements. Yet pilot accounts from actual combat consistently highlighted improved climb rates as absolutely crucial in these victories. The Curtiss Electric C5R42S paddle blade model, the most prevalent version, carried 4 blades spanning 13 feet in diameter. Each blade covered substantially more surface than the older thin blade designs. This expanded area delivered dramatically increased thrust at lower airspeeds. The Hamilton Standard Hydromatic paddle blade, fitted to later P-47 production models, delivered comparable effectiveness with practical advantages. This Hamilton design employed hydraulic pitch regulation, offering improved simplicity and dependability over Curtiss electrical components. Total blade surface was virtually equivalent, and pilots reported nearly identical combat behavior. Outfitting the P-47 fleet with these propellers showed American manufacturing might operating at tremendous volume. Both Curtiss-Wright and Hamilton Standard fabricated thousands between June 1943 and the end of 1944. Each assembly contained 4 blades, a hub structure, pitch control gear, and fastening components. Blades went through forge processes using aluminum compounds, got machined into exact aerodynamic profiles, and underwent heat treatment to build maximum hardness. Per blade meant some 14 hours of machining alone, excluding raw stock preparation and surface finishing. Moving these propellers to combat zones in England posed serious logistics difficulties. Each complete unit weighed around 650 pounds, demanding careful transport to prevent shipping damage. Workers packed propellers in wooden crates with shock-absorbing supports and loaded them onto transatlantic cargo ships. These voyages typically stretched 14 days. Upon reaching English soil, propellers traveled to maintenance depots where technicians mounted them on fighters. Mounting work consumed roughly 16 working hours per aircraft, encompassing old propeller removal, new unit installation, pitch control calibration, and testing on the ground. Through the first half of 1944, depot crews in England retrofitted above 1,000 Thunderbolts, while keeping frontline squadrons combat-ready. Paddle-blade Thunderbolt tactics continued developing through summer and autumn 1944. Pilots refined their methods to capitalize on climbing advantages. One especially potent maneuver was the vertical scissors, where two Thunderbolts attacked a single German fighter in an extended climb. While the first P-47 pressed upward, the second positioned for an assault once the enemy plane ran out of energy and couldn't climb further. The German pilot faced an awful dilemma: keep climbing until the wings stall, turning him into a sitting target for the trailing American, or level out to maintain airspeed, allowing the leading Thunderbolt to reverse into a diving strike. Paddle blade versions gained importance for low-level ground attack duties. Increased low-speed thrust permitted fully loaded P-47s to sustain velocity and control, even carrying 2,500 pounds in bombs or missiles. Pilots striking ground targets dove from shallower angles, reducing seconds spent exposed to anti-aircraft weapons. Once ordnance fell away, paddle-blade Thunderbolts accelerated upward faster, minimizing time vulnerable to ground fire. From April through September 1944, Thunderbolts flew more than 88,000 ground support missions while sustaining roughly 820 total losses, representing less than 1% casualties. The adaptability meant paddle-blade Thunderbolts remained frontline machines, even as the faster P-51 Mustang became available. Numerous fighter groups deliberately held on to Thunderbolts because improved climbing made them remarkably versatile for multiple purposes. The 56th Fighter Group, commanded by Colonel Hubert Zemke and later by Colonel David Schilling, stuck with Thunderbolts for the entire conflict, despite chances to convert to Mustangs. The pilots reckoned the tough airframe and 8-gun firepower, paired with the terrific climbing courtesy of paddle-blade propellers, beat what Mustangs provided for their needs. Surviving German fighter aces universally acknowledged the paddle-blade Thunderbolts as among the most formidable American fighters in the skies. Major Günther Rahl, finishing with 275 confirmed kills, described in post-war interviews that the upgraded Thunderbolts posed far greater danger than earlier versions. Rahl told fellow pilots that they had to grant paddle-blade Thunderbolts the identical caution they gave P-51 Mustangs, accepting that the American machine matched German capability across virtually every aspect. Engineering insights from this effort shaped subsequent American fighter improvements, demonstrating that steady upgrades to proven fighters often delivered greater value than creating brand new designs. The P-47 received continuous enhancements past the propeller work. Water methanol systems pumped engine output to 2,535 horsepower for brief durations. Combined with paddle blade thrust characteristics, this pushed performance higher still. The P-47M, arriving in autumn 1944, combined both upgrades and achieved rapid ascent, matching or surpassing German climbers. Investment needed to create and roll out paddle blade propellers stayed small compared to the results achieved. Work on both Curtiss and Hamilton models, including aerodynamic research, test aircraft construction, and flight validation, ran roughly $3 million total. Building a completely new fighter would have needed minimum $100 million spending and 2 or 3 additional years before combat operations started. The paddle blade represented the kind of economical improvement keeping American fighters ahead. These propellers illustrated how crucial the connection between combat units and engineering teams proved. Pilots identified the narrow blade weakness through frontline experience, recording technical observations in detailed reports. Intelligence channels processed these reports and delivered them to engineers capable of recognizing the core issue and devising countermeasures. Problems encountered in active fighting translated into practical answers within months through this circuit. Germany theoretically had matching systems for this, but the country's collapsing strategic situation increasingly scrambled these communication networks. Consequences stretched further than just air-to-air fighting. Creating air dominance over Europe to which improved Thunderbolts substantially contributed, enabled American ground troops to progress with hardly any German aerial opposition. When American forces pushed out of the Normandy beachhead in August 1944, they advanced under continuous fighter protection supplied principally by Thunderbolts. German ground units attempting withdrawal or repositioning faced relentless strikes from Allied air. The climbing improvements allowed German fighters attempting to stop ground attack operations to get rapidly engaged and beaten by escorting Thunderbolts. The most significant paddle blade Thunderbolt engagement came during the Battle of the Bulge, spanning December 1944 into January 1945. When German ground forces mounted their surprise Ardennes push, thick weather initially prevented air operations. Upon clearing on December 23, Allied air forces released a flood of strikes hitting German ground units and supply chains. Paddle blade Thunderbolts flew hundreds of daily runs, pounding German tanks, transport vehicles, and gun emplacements. Luftwaffe fighters scrambled to intervene but got repeatedly pushed away by protecting P-47s. By February 1945, organized German fighter resistance over Western territory had collapsed entirely. German fighter squadrons shifted toward homeland defense against mounting strategic bombing attacks. Paddle blade Thunderbolts had significantly shaped this air dominance. Though the P-51 Mustang enjoyed more celebrated reputation, some military writers examining that air war have underestimated the Thunderbolts' contributions. Focusing on P-51 victories and operations deeper into Germany. But this perspective misses something essential. The Thunderbolts' improvement through paddle blade modification coincided with Germany's fighters still presenting genuine threats. Throughout 1944, Thunderbolts shot down 3,082 German aircraft in aerial combat, while losing 824 P-47s throughout the European campaign. This calculated to an overall ratio of 3.71 kills per loss, equal to or exceeding other American fighter types during identical months. Significantly, the Thunderbolts' transition from marginal climber to genuine vertical fighter happened during the exact period when climbing ability meant everything. Post-war history of paddle blade Thunderbolts demonstrates how speedily wartime breakthroughs fade away. Once jet fighters appeared, propeller-driven P-47s quickly faded into history. Most intact Thunderbolts got scrapped or transferred to foreign air services. The engineering skill enabling paddle blade Thunderbolts to succeed got buried beneath the revolutionary jumps jet propulsion represented. Limited numbers of pilots who operated upgraded Thunderbolts occupied positions where they could champion proper historical remembrance of the propeller modification. Yet paddle blade propellers warrant substantial historical credit as a military innovation category. This wasn't some transformative revelation that fundamentally rewrote air battle rules. This was sensible enhancement, taking an available aircraft and solving its greatest flaw through straightforward engineering. Such improvements, less dramatic than revolutionary breakthroughs, frequently matter much more immediately. American triumph throughout World War II rested substantially on precisely this: the capacity to notice issues, generate workable answers, apply them successfully, and distribute them across vast operations provided American forces insurmountable strength. The technical foundations of paddle blade engineering maintain contemporary applicability well into the jet age. The central principle that blade sizing must serve the actual operating environment, rather than chasing perfect numerical efficiency, applies to jet turbine blades, chopper rotors, and drone power plants. Military designers persistently balance competing performance requirements across various flight conditions. German understanding of paddle blade Thunderbolts offers instructive warnings on industrial and strategic constraints. German specialists grasped propeller mechanics identically to Americans. German industrial works possessed capability to fabricate superior propellers had materials and capacity been allocated, yet Germany's weakening strategic condition, material limitations, and progressively fractured manufacturing base prevented rapid modernization. Victories don't come from individual superweapons, masterstroke tactics, or singular innovations. They come through accumulated strength of 10,000 incremental improvements, addressing specific gaps, executed resourcefully, and contributing progressively to technological superiority. The paddle blade represented a single modest upgrade amongst countless others, arriving when German resistance still posed legitimate challenge. Erasing the Thunderbolts' climbing limitation accelerated American air command and expedited ultimate German collapse. This accomplishment emerged from laborious work by propeller technicians, rather than celebrated combat legends and merits recognition as a truly critical factor in European victory.